So we are at our last section of activity 15 today. We're going to talk about properties of rectangles, rhombuses, and squares. So we have a lot to cover today in this video, so let's go ahead and get started on page 216. Okay, so on 216 we start with a rectangle, and they say a rectangle is a parallelogram with 4 right angles. So in the last video we learned about parallelograms. That means that our opposite sides are parallel to each other. So this is a parallelogram, but it just happens to have 4 right angles. So all of our angles, so angle R, angle E, angle C, and angle T are all 90 degrees. Those are right angles. And since it's also a parallelogram, we learned in the previous video that the diagonals of a parallelogram, so meaning the diagonals of a rectangle, are congruent. Okay. So we know that's true because we learned that in the previous lesson. So a rectangle is part of the parallelogram family. Okay, so it's a parallelogram. It just happens to have 4 right angles. So the other properties about rectangles, okay, is we know that their opposite sides are congruent and parallel. We just talked about the parallel part. We also know that their diagonals are congruent and they bisect each other. That was that theorem from the previous video also. So they bisect each other. That means these are all congruent. Okay. Another thing we know about rectangles is all their angles are 90 degrees. So all their kind of vertex angles. So let's do a couple problems with some rectangle properties. So number 6. So given this quadrilateral TGIF, and they're telling us this is a rectangle. So use the properties to find the following. So in this first one, they gave us TX. They say that TX is 13. We need to find what TI is. We need to find the length of that entire diagonal. Well, the diagonals bisect each other. So if TX is 13, so is XI. So if I add those up, I'll get the length of the entire segment. So 13 plus 13 is 26. Okay. What about the length of FG? Can you guys find the length of FG for me? Well, FG is just the other diagonal, and we know from our properties the diagonals are congruent. So if TI is 26, so is FG. Okay. All right, let's look at B. We're going to solve for x if TX is at 4x plus 4. So let's erase this and get a clean picture. So if TX is 4x plus 4, okay, and FX is 7x minus 23. Okay, so setting this problem up, we know that the diagonals bisect each other. So what that tells me is that all my segments in here are all congruent. Okay, they're all congruent to each other. If they bisect each other, they give you 4 congruent little parts. So to set this up, all we'd have to do is set these equal to each other. This is for B. So we have 4x plus 4. We're going to equal that to 7x minus 23. So can you guys solve that for me and go ahead and finish this problem? Okay. If you solved everything correct, you should have got that x was 9. We'll put that on in there. Okay. Last one, let's talk about solve for x if angle XFT. So let me erase this again so I can get a clean picture. So angle XFT, that'd be this angle here, is 6x minus 4. And angle XTG, so that angle is 10x minus 2. So we kind of think about how we set this one up a little bit. So we know that the diagonals bisect those angles because it's part of a parallelogram. So like these angles have to be congruent. And those angles have to be congruent because they bisect each other. So we can kind of set this up knowing that this angle, okay, TFX is congruent to angle X. Maybe I'll use a color here. This angle and these angles are congruent. So are these angles and these angles. So we kind of have to set this up knowing the fact that we have kind of two angles. If we add them together, what is the whole measure of this side? Well, if it's a rectangle, it's 90 degrees. So to set up this equation, I'm going to take 6x minus 4, add it to 10x minus 2, and equal it to 90 degrees. Because those are two angles. If we add them together, they're going to give us that right angle property for a rectangle. So if I clean this up, what do we get? 16x minus 6 is equal to 90. So if we finish this problem, we add 6 over, divide by 16. We should get that x is 6. Okay. So again, a rectangle is a parallelogram, has all the same properties of a parallelogram. The only thing that's different is that all vertexes are 90 degrees. Okay, let's move on to our next shape. So I'm going to skip this page and jump to page 218 here, where we learn about a rhombus. So a rhombus is a parallelogram with 4 congruent sides. So let's maybe just draw a picture here. Let me get a rhombus. So a rhombus would look like this, and it's a parallelogram. So again, we still have our parallel sides. And what makes a rhombus special is that all of your sides here, okay, are congruent. So you have 4 equal sides. So it means this side, this side. So similar to a square where they're all congruent sides. Okay, so let's kind of talk about some properties of rhombuses then. Let's scoot down here. The diagonals of a rhombus, because they are, okay, a parallelogram, they are going to be congruent like before. Drawing another diagonal here. But what's special about the diagonals for a rhombus is they are actually perpendicular. Okay. So here's a picture of a rhombus here. They're using this rhombus EFGH. Okay. So on a rhombus, we know all 4 sides are congruent. And we also know that it's special because your diagonals form a right angle. They're perpendicular to each other. Okay. So that's one property of a rhombus. The other one we're going to do here is that each diagonal from a rhombus bisects a pair of opposite sides. So bisects a pair of opposite sides. Okay. That is our other property of a rhombus. So let's do some problems on the next slide here. Oops, I missed where it has us list all the properties. Sorry about that. So listing all the properties of a rhombus is that their opposite sides are parallel. They are also congruent. Okay. Opposite angles are congruent. Okay. Their diagonals bisect each other, so all their diagonals are congruent. The diagonals are perpendicular, and all sides of a rhombus are congruent. So we're going to use this to answer some questions now in the next slide. So we'll put those in our family tree tomorrow during notes, but here is a quadrilateral Utah, U-T-A-H, and they're telling you it is a rhombus. So use the properties to solve for x if angle UPT, so this angle here, is 4x minus 18. So what do we know about all the angles here where our bisectors meet? They have to add to what? Okay. Remember, our diagonals are perpendicular. So if they're perpendicular, we're just going to set 4x plus 18 equal to 90 degrees, because all of these angles here need to be 90 degrees. So UPT is 90 degrees. So set that up and solve for x. We should get that x is 18. Okay. All right, let's look at B here. I'm going to erase this so I get a clean picture. But in B, it says solve for x and y if ut is 5x plus 4. Ut is 5x plus 4. We know that TA is 2x plus y. HA is 2y minus 8. And lastly, UH is 24. Okay, so we could set this up using a system, but I have a little trick for you. In a rhombus, all sides are congruent. Okay, we know that's special about a rhombus. So instead of solving this as a system, I'm probably not going to use the side TA at all, because that has x and y in it. But instead, what I can do is I can set up 2y minus 8 is equal to 24. But I can also set up that 4x plus 4 is also equal to 24. If all sides are equal, you can set up the equation however you want. So 5x plus 4 equal to 24. If we solve this, we should get 5x equal to 20. So x we get is 4. So we didn't actually need a system at all. Same thing if I solve for y, I can set 2y minus 8 also equal to 24. So if I add that over, let's see, 2y, 8 plus 24 is what, 32? So if I divide by 2, I'll get y is 16. You get x is 4, y is 16. So that's why we like the rhombus, because it's special in the fact that you have all 4 congruent sides. So there were some options here on how we could have set up that problem. I just chose to set it up using linear equations instead of a system. Okay. All right, the last shape we have to cover today is the square. And we are probably already familiar with a square. But a square is a rectangle. So it fits under the rectangle category, just has 4 congruent sides. Okay, so all sides on a square are the same, similar to a rhombus. And a square is a rhombus, but it just has 4 right angles. So that's why it's similar to a rectangle, because it has those right angles at each of our vertices. And it's similar to a rhombus because it has 4 congruent sides. So that is a square. So all the properties that apply to a rectangle also apply to a square. All the properties that apply to a rhombus also apply to a square. So if we list all of our properties here, it has 4 congruent sides. All the angles are 90 degrees. Opposite sides are parallel. Diagonals bisect each other and are congruent. And the diagonals bisect at right angles. Okay, so again, all of these are congruent as well. And your angles are perpendicular, diagonals. They bisect each other at right angles. So they're 90 degrees there, perpendicular. So a square actually has a lot of properties to it. Okay, so again, it's kind of combining a parallelogram with a rectangle with a rhombus. That's your square. Okay, so we're going to go over our family tree tomorrow and put in all these properties, but those are all of our quadrilaterals. So today we did cover quite a bit because we talked about parallelogram. So just kind of go back and recap really quick. So a rectangle is a parallelogram. It just happens to have 4 right angles. Okay. Your diagonals are congruent. They bisect each other. So we have all those properties. Then we have our rhombus. So a rhombus has 4 congruent sides. The diagonals bisect at 90 degrees. So we have that. And then that leads us into a square. So a square is a rhombus with 4 right angles. It's a rectangle with 4 congruent sides.